Hello students. Today we will discuss about the linear induction motor. Linear induction motor means a motor which gives linear or translational motion instead of rotational motion. Let's see here. This is the polyphase rotary induction motor which we studied earlier. So this is the rotor and this is the stator. On stator there is a three-phase winding and this is the rotor which is a wounded type rotor. Let the stator cut along the line AB and spread out as shown in figure. Means from A to B we cut this part and spread along this axis. So it will look like this. Means here this is the stator winding, three-phase winding, and this is the rotor winding which is our rotor. Here the stator is called as a primary winding and rotor is called secondary winding. And the secondary of a linear induction motor consists of a flat aluminium conductor with a ferromagnetic core. As in rotary induction motor, when we connect the three-phase supply to the stator, a rotary flux or revolving magnetic field is produced. Similarly, when we connect a three-phase supply to the linear induction motor, a traveling flux is produced instead of rotary magnetic field. This traveling flux is produced that travels along the length of the primary, and due to this current is induced in the aluminium conductor due to the relative motion between the traveling flux and aluminium conductor, and the induced current interact with the traveling flux which produced a linear force or a linear thrust. So in linear induction motor, if we fix the secondary winding and primary is free to move, the force will move the primary in the direction of traveling wave. This induction motor, this diagram is called a single-sided linear induction motor. What is? This is single-sided linear induction motor. Let me show the double-sided linear induction motor. This is the double-sided linear induction motor where the primary is at both the side of the secondary. So it has primary on both the side of the secondary. So this is called a double-sided linear induction motor. This is a single-side linear induction motor. Okay. Now, as compared to the rotary induction, the linear induction motor requires a larger air gap. As we studied in three-phase induction motor, the air gap is always smaller as possible as. So, but in linear induction motor, the air gap is larger. Therefore, the magnetizing current is larger and the power factor and efficiency are lower than the rotary three-phase induction motor. Okay. Here one more thing. The speed does not depend on the number of poles but only on the pole pitch and stator supply frequency. What is the pole pitch? Pole pitch is the distance between the two poles. So when we calculate the speed in linear induction motor, it would depend on the pole pitch and the stator supply frequency. Hence, the synchronous speed is given by Vs is equal to 2 into W into F, where Vs is the linear synchronous speed which is given in meter per second, because here the motion is linear, motion is translational traveling wave. So we will consider here the velocity instead of the RPM. So Vs is the synchronous speed for the linear induction motor, which is given in meter per second. W is the width of one pole pitch, which is given in meter, and F is the supply frequency. Here, as in three-phase induction motor, in a rotary induction motor we give the slip. Here the equation for the slip is Vs minus Vr upon Vs. As in rotary induction motor we know Ns minus Nr upon Ns, and here we are considering velocities, so Vs minus Vr upon Vs. Vr is the actual speed. Thrust or force can be given by P2 upon Vs. And what is P2? P2 is the active power supplied to the rotor, which we known in three-phase induction motor is a air gap power as we given as a Pg, but here it is given by P2. And this is the losses, copper losses, which is given by S into P2. As in three-phase induction motor we have given S into Pg, and the mechanical power developed Pm is given by the 1 minus S into P2, as we have given in three-phase induction motor 1 minus S into Pg. So that's all. This is the linear induction motor. And what are the application of this linear induction motor? The main application of the linear induction motor is in transportation, including electric traction motors. Especially it is used in electrical traction, where the secondary would be track and primary would be the fitted on the vehicle. So in a traction system this motor is always used. Thank you student. If you have any doubt you can ask me. So I will provide you the PDF also. So study it well and stay healthy. Thank you. Have a nice day.